In this experiment, we are going to develop IoT-based intruder detection and alert system. So, what is this intruder detection? So, in this particular experiment, intruder means unknown person, theft, thief, or any other person who will harm your property, your any instinct. Okay, so this intruder should be detected. So how you can detect this intruder? So we are proposing right here one sensor, that is SCSR04. This is ultrasonic sensor. So this particular sensor will detect this intruder, and it will send the information to our mobile phone, and we will get some alert based on this particular sensor. Okay, so generally this HCSR04 sensor is used for ultrasonic type of detection. Okay, so here it send the signal toward the object, and it will receive that signal back, and it will calculate the distance between the intruder and the sensor. And if that particular distance is in uh, below that threshold level, then automatically it will sense that someone is entering at your home or any security place where that person should not be present. So it will send that alert system to your mobile phone. Okay, you can see right here all these components which you are able to see. We have already discussed all these components in the previous session. Okay, all these are the old components, so we will not discuss these. This one is the new sensor which today we will discuss in detail. Okay, so this sensor is used for the security alarm system, and we can detect this intrusion to protect some unauthorized entry into some building areas, into some schools, into some security places, residential places, commercial places, industrial places, and military also. Okay, and we can protect against the theft or this burglary, and we can protect our property also. Okay, and this particular system is very much essential for the security alarm system, and we mostly see in residence areas, uh, and we protect theft from these areas by placing this type of sensor over there. And we also place this sensor in the car alarm system to protect the vehicle and their contents. And prisons also use this type of sensor to provide the security system and the control. Okay, so how to make such a project? For the notification purpose, we are simply using this IFTTT.com website. So this particular website will provide us to design an applet based system, so that will receive the information from your device, and that information will be sent directly to your mobile application. Okay, so here we can design the applet, and with the help of that applet we can create a webhook. Okay, and through webhook we will send a web request to receive the particular notification, and that notification is to be sent to the IFTTT application which you have already installed in your mobile phone. Okay, so same process we will follow right here also. Okay, we are just creating a notification applet over IFTTT.com website, and we will send that information directly to your mobile phone. Okay, so this is the first part of your experiment. Then we will create the hardware. Okay, to create this hardware, you can see the schematic diagram of this particular circuit. Here we are using ESP32 module, and that ESP32 module is connected with pin number 9 and pin number 10 to this HCSR04 sensor, that is ultrasonic sensor. Okay, so this pin number 2 is a trigger pin that is directly connected to pin number 9, okay, of ESP32 module, and this is a echo pin, which is 3 number pin, that is directly connected to pin number 10 of ESP32 module. Okay, so this is very simple type of connection. Only these two pin, 9 and 10 pins of ESP32 module is used, and 9 pin is directly connected to pin number 2 of this SR04 ultrasonic sensor, and pin number 10 is directly connected to echo pin of pin number 3 of this SR04 ultrasonic sensor, and pin number 1 is connected to plus 3.3 volt power supply, and pin number 4 is connected to the ground pin. Okay, so that's all about the connections of this ESP32 module. Okay, here you can see only 4 places you need to modify. This is pin number 7, line number 7, 8, 10 and 11. These are the 4 lines which you require to modify. Okay, so first we need to modify your Wi-Fi SSID. That Wi-Fi SSID should be uh, that which is connected to your ESP32 module. Okay, and password is similar, which is available with the connection with ESP32 module. So you have to put both these Wi-Fi SSID and password. So we are using the hardware in our lab, so we will put Wi-Fi SSID as B6-lab702. Okay, and we are not using any password, so we will left it blank. So this is the modification you need to apply right here. Then you have to modify these API keys and the event name. So right here you can see this is the API key which we have generated by IFTTT.com website. So you need to modify this key. After that, we have to modify the event name. So we will create the event name and we will modify that event name similar to which we have created in IFTTT.com website. And you can see right here we have connected these pins to the trigger and echo pin, and we will set initially the threshold value to the 100 centimeter. If someone is coming near to this particular distance, then it will automatically detect this distance. So how you can detect this distance, we will see in the programming. Okay, we will explain this program in detail. So after how to design your circuit, you have to use the fritzing software to design this particular circuit. Okay, so using your fritzing software, you will place ESP32 module right here, and you have to place these pins, pin number 9 and pin number 10, and these pins should be connected to your this particular ultrasonic sensor. Okay, one pin is echo pin and second pin is trigger pin. So this trigger pin is directly connected to pin number 10. Okay, and distally we can denote this pin as 18 and 19, as you have seen in your Arduino code. So these name are defined as 18 and 19. Okay, so you can see right here in the code. So this is pin number 18 and pin number 19, and why we have defined this pin number 18 and 19, you can see this is a distal pin 18 and this is a distal pin 19. So you have defined its logical name, okay, not physical. So this is a physical pin name number, that is pin number 9 and pin number 10, but logically we will define these pins as distal pin 18 and distal pin 19. Okay, so we will use the logical name of this particular pin. Okay, so distal 18 and distal 9, these two pins are used. So you can place these names right here in the coding part. Here is 18 and 19. Okay, so that's why we are using echo and trigger pin right here. So echo is connected to pin number 9. Okay, and trigger is connected to pin number 10. So you can calculate right from here: 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is ninth number pin, and this is 10th number pin. And as usual, we will connect this capacitor to the last enable pin. Okay, logical name is enable, and physically this is the last pin number. So physically with this capacitor pin, last pin of ESP32 is connected to positive of the capacitor, and negative of the capacitor is connected to the ground. So this is a common ground. Here you will connect all the common grounds. Okay, you can see all these grounds are connected commonly right here, and this pin is connected to ground, and this pin is connected to VCC. So here you will provide 3.3 volt power supply from this battery connection. From here you will provide 5 volt power supply. Okay, so this is the particular connection which you can create through your bridging software. New notification applet from here. So how to create a new notification applet from here? This is a create option on the right hand side of this particular website. You have to click on this create option. It will ask you what you have to do. Okay, the name of this IFTTT website is based on this particular syntax. If this happen, then what to do? Okay, or what you have to do? Okay, so you have to click on this add option, and you will search for the webhook. So why we are designing this webhook? Generally this webhook will receive HTTP request. Okay, so it will receive a web request. Okay, when you trigger something on the hardware. So we will click on this receive a webhook option, and we will connect this webhook with the HTTP server, and it will initially ask you permission to give the access to connect your HTTP server. Okay, and after that you have to provide the event name, which event you want to create. So we will create right here intruder detection event. Okay, so I will give the name like this, and I will create this trigger. So after creating this trigger, what we have to do? We have to send the notification to your mobile phone. Okay, so we will click on this add option, and here we will search for the notification. Okay, here we will search for the notification, and we will select that notification right here, and you have to send that notification to IFTTT application. So we will use this option from here, and we will send a message to your mobile phone. Okay, so what message you want to send toward your mobile phone, it's your choice. Okay, so I am writing, okay, I'm writing same intruder detection at, you have to give the date and time. Okay, so you have to click on this add ingredient, and occurred at will be used to get the date and time of your system. Okay, so this message will appear intruder detection at this date and time. Okay, and you have to, if you want to give the value, how much distance is there in between that intruder and your doorbell. Okay, you will provide that distance. Okay, so you will give the value, the distances, and you add the value. So we will record that value in variable value 1. So we will define the value 1, and we will create this section. Okay, so this applet is created with the notification. So I will click on continue, and this applet will give the title as if maker event intruder detection will happen, then send a notification from the IFTTT application. So it will send a notification. So I will click on this finish option, and you will see this notification is created right here. Okay, so our next step is to add all the keys of this particular applet into Arduino code. Okay. For that, what we have to do, we have to click on this webhook right here, and we will see on the right hand side, this is a uh, documentation button, and you have to click on this documentation button. So when you will click on this documentation button, you will see the key is available right here. Okay, so you have to place this particular key to send a notification to your mobile application. Okay, so we will use this key in Arduino code. So what we will do next, we have already downloaded all the codes in document folder, Arduino folder, and then all the codes are available right here in experiment codes. Here you will find T8 underscore intruder alert system. So I will open this folder, and you will find the file name is T8 underscore intruder underscore alert. Okay. So this is Arduino file. You have to double click on this particular file, and when it will open, you have to edit this particular file to give the key value and the event name which you have created. Okay, so you have opened this code right now. So what we need to change in this code, so we need to change these 4 lines right here. So this is the Wi-Fi SSID. Right now we can use the lab, which is b6 underscore lab 702. So you will put the same Wi-Fi SSID right here. We are not using any password, so we will left it blank, and we will modify this key. Okay, so I have already copied this particular key from ifdd.com website. So I will paste this key right here. Okay, so you can see right here in this particular key. I will copy it again, and I will paste right here. Okay, you will see this key is changed right now, and I have to place the same event name which we have created. So intruder underscore detection is the event name, and you can see in your IFDD account what is the name. So same name is available right here, intruder underscore detection. Okay, so if this name is different, you will copy this same name and paste this same name inside the Arduino code. That's all. These are the modification. So let's understand this code first. What we are doing right here, we are including the Wi-Fi header file, which will access which will give access to get the information from the hardware, and that information is to be sent through Wi-Fi module to that HTTP server which we are using right now. Okay, and then we are using this ifdd webhook.h. This is a header file that will enable us to connect our particular application applet with this webhook. Okay, or with this Arduino ESP32 Wi-Fi module. Okay, so these 2 header files will be included right here. After that, we are defining all these information which are necessary to connect our hardware with the HTTP server. Okay, and we are connecting our this ultrasonic sensor to the ESP32 module. So the physical pin number is different, but we are using logical pin number. So distal 80 number pin is used for the trigger, and distally 19 number pin is used for the echo. So we are defining these 2 pins right here. So which pin is connected to which particular pin of your ESP32 module. So trigger pin is your ultrasonic sensor pin that is connected to pin number 18 of ESP32 module, and echo pin is also the ultrasonic sensor pin that is connected to pin number 19. So these are distal pins, and we are defining the threshold value right here. So we are defining in centimeter. So this particular sensor is not a commercial type of sensor. It will detect small range. Okay, So when you use a commercial type of sensor, so that particular sensor give you wide range. Okay, so right here we are providing 100 centimeter range to this particular intruder detection, and we will use the function right here. The function is IFTTT underscore babu. In this function, we are passing two variable. One variable which we will pass as a key, API key, and second variable we are passing the event name. So we are passing these two variable to access the applet. Okay. So here we will use this function to get the distance value. Okay, and here you can see right here the distance is calculated with the help of this condition. If this start from here, if this distal right pin is district right pin. What do you mean by distal right? Distal right means you have to make the pin active low or high. Okay, based on this distal right, you can write on that particular pin. So initially we will put this trigger pin to the low, that means it is off. Okay, so we will provide a 2 millisecond of delay. So initially that trigger pin will be off for 2 millisecond. Okay, then we are setting this trigger pin to high state for the 10 microsecond. Okay, so we are placing this to the high, then we will provide a delay of 10 millisecond. Then again you use the low pin, and we will put that trigger pin to the low. Okay, so initially when we want to detect some obstacle, okay, or object or intruder, that distal pin is using to sense the obstacle. Okay, so every 2 seconds it will be off, and every 10 second it will be on. So this process will continue. Okay, and it will calculate the distance when this trigger pin is on and this echo pin is high. So when this echo pin will high, if the obstacle is within the range, then this obstacle pin is high, then it will calculate that distance. If that distance is below the particular threshold level, then it will send an alert system. So this is the particular function which will use to calculate the distance. Then we are set up this Wi-Fi module, and we will communicate through this Wi-Fi module to our applet, IFTTT applet. Okay, so here initially we will set a baud rate. That baud rate will be used to communicate serial communication. Okay, and we are printing that this alert system is generated, and we are setting these pins as a input and output because this is a setup function. So we will define the each pin function. So trigger pin is used for the output. It will give you the alarm system, and echo pin is the input that will receive the signal from that sensor. Okay, so this echo pin will receive the input, and trigger pin will give the output. Okay, then you will connect with your Wi-Fi module, and you will check this Wi-Fi signal using this two variable Wi-Fi SSID and password. If both these are correct, then you will run this while loop. Okay, continuously it will check. Okay, if this Wi-Fi is connected, so continuously it will checking this Wi-Fi signal, and it will send that information to the HTTP server which is connected right here. Okay, then you are printing the information that this Wi-Fi system is connected correctly, and you will use this loop function to perform the continuous operation. So continuously what this particular function is doing, it is getting the distance, okay, from that particular sensor, and if this particular distance is below the threshold level, okay, then it will send the signal that this intruder detection is detected, and you have to take some action. Okay, system virtually with the help of this particular application, you can put the event name right here. Okay, so what is the event name? You can see this is the event name. Okay, you will use the same event name right here, and you will test this system virtually. Okay, So I am placing the event name as intruder detection, and I am placing the value as 99, and I will trigger this test test it. Okay, I will click on this test it, and you will see the notification in your mobile phone if you have installed that mobile application. This intruder is detected, and the threshold level, it is showing as 99, which is placed right now. Okay, so I am changing this value to 98. Okay, and I will test it again, and you will see within a few seconds this notification will appear in the mobile phone. Okay, so